Hi everyone, are you able to hear me clearly and see my screen clearly? You can reply using the chat and you can ask questions using the Q&A window. All right, so great, great to have all of you in the session. So the agenda for today's session is that we'll first go over the introduction of machine learning. This is something that if you have already attended machine learning sessions, this is something that you will be comfortable with. The second part is about deep learning, as in we are going to do the hands-on. We're going to do the hands-on on TensorFlow. Okay. For this part, you will require access to the lab. Otherwise, you can also set up on your own machine, and but that would not be easier to set up as compared to just signing up for the lab. So in case you are in case you want to do the hands-on, I would request that just if you have not already created an account with CloudxLab, just sign up for the free account. You will get the access to the lab, and then you can easily use the TensorFlow. Just that while signing up, it might require a credit card that will do a $1 transaction, but that will be refunded after. Yes, the session is getting recorded, so no worries. After the session, we'll be sharing with you the presentation along with the recording. All right. And between the introduction to machine learning and hands-on with TensorFlow, we're going to have 10 minutes break, 90 minutes from now. Okay. So that's basically the agenda. We'll talk about the machine learning first, and then we'll talk about hands-on. But this is not necessary that the 10 minutes break will be exactly in the middle. Okay, so this will be for uh, this will be for around 120 minutes, or maybe say 100 minutes, and remaining will be this one. Okay. All right. So great, great. All right, welcome all, and let's jump in. So first of all, this introduction is similar to the introduction to machine learning in general. So here we are generally going about understanding the meaning of machine learning and deep learning. Okay, so all right. So what do you see on the screen? To a question to all, you can reply using the chat, and you can ask questions using the Q&A window. There are two windows. So what do you see on the screen? The three photos on the left hand side. On the left hand side, you see anybody? There are three photos: this, and this. What do these three photos mean to you? Yes, right. So this one is a photo from a movie called Ex Machina, and this one is from Matrix, and this represents data, and this represents the robot. So, so the idea here is that the idea that I want to portray is that this is the fantasy, and this is the reality. As of today, probably this is the most sophisticated robot, and this is a robot from the from Boston Dynamics. Thank you. And the the way to reach the fantasy, which is the sophisticated level of a human level intelligence, We need data. All right. This is the agenda with machine learning. This is the agenda with deep learning, and so on. Okay. So, so to start with, since we are going to do hands-on in this session, so you can start signing up now, and during the break or by the time we discuss the theory part, you can actually finish signing up. And this will give you the free access to the lab so that we can all do the hands-on. The idea is that we all must do the hands-on. So this is the first session of deep learning course. Here we are going to do general introduction and then we'll get started with the TensorFlow. All right, we'll just do first hello world kind of TensorFlow, and we'll understand the general concepts about TensorFlow towards the end. All right. So also please feel free to introduce yourself using the chat window and use the Q&A window to ask questions. Okay, to ask questions. Great, great. So let me first introduce CloudxLab a bit. So at CloudxLab, we are trying to make learning fun and for life. All right. So how are we making learning fun and for life? One is by the videos or by the live sessions like these, and by the way of quizzes, by the way of hands-on, and by the way of projects, and by the way of case studies. And all of these are based on the real life use cases. All right. The hands-on is something that we have worked on probably more than anybody in the industry. So the idea with hands-on is that when you are working in the lab, you should be able to evaluate and assess whether you are going the right direction or you need assistance. Okay. So the hands-on basically checks your work. There's an automated hands-on assessment. That's what we are the pioneers of the lab, the cloud-based labs. And at the cloud-based lab, when we have everybody is working in the lab, then it is easier for the system to evaluate whether you're doing good or not. Okay. A question from Amandeep is, which all universities are supported by CloudxLab for 30 days free access? Any institution whose domain name ends with .edu and or the domain name that ends with .ac.in. All right, that was a question from Amandeep. AC dot country name. So the second level domain should be AC. Okay, so it should be AC.in, AC.uk, AC.us, AC.sg, and so on. Second level domain must be AC. Wonderful. Now, so all right. All right. So there are a few users who have already access to the lab, not able to get the access because they've already taken the free trial. Kindly, somebody from my team would extend if you just give your email ID. Wonderful. So this is about CloudxLab. We want to make learning fun and for life. So, so the core idea behind hands-on assessment is you learn by doing, and that's probably the only way to learn. Okay, so you will get a problem statement. You will have to do the assessment in the lab, and then it will check whether you're doing or not. Say for example here what you see is a very simple assignment where you have to just log in into the lab, and then it will basically then you will click on I'm done, please check. Then it'll do the evaluation. Here is another example. On the left hand side, you see a question. You see a question that uh, define x as 10. And then you define x as 10 on the right hand side. And then if you click again, you'll get a good job. Similarly, many such assessments have been made, and we are still working on adding more and more questions. And many people are contributing to it. So this is a hands-on assessment system which helps people learn technology, learn anything that could be done in the lab, and so on. All right. So the course objective is to learn deep learning with TensorFlow. All right. So about myself, I'm Sandeep Giri. I did my graduation from IIT Roorkee. I worked mainly on the large scale computing so far. And I worked with Amazon. I worked with InMobi. I worked with a company called DE Shaw. And in between, I also founded a company called Tibets Global in Hyderabad in India. So I'm a software engineer at heart, and I love explaining technologies. And that's the reason why we started CloudxLab, which was earlier called No Big Data, KNOW Big Data. All right. So that's about myself, and please feel free to introduce yourself using the chat. Okay, I may not be able to read it now, but I would go through the chat again after the session to know a bit more about you. All right. So all right. The question is, who is the let me just answer a couple of questions, then I will take questions after a while. So who is the ideal user or student of CloudxLab? Anybody who wants to learn machine learning, big data, or similar technologies like Python and Scala and others. So everybody is the student of CloudxLab. Okay, whether they are still studying or they're in the college or whosoever it is. Okay, so great. All right. So you can, because we are going to work on the CloudX Lab at later point of time, I would suggest that since we are going, if we can, so you can set up your own TensorFlow, it'll be great. Or an easier way would be just sign up for the CloudX Lab, enroll for free access. If you're facing any error, just ping the team. So one of my teammates will take a look at it, and that should be good. All right, let me just see if I can take a look at my teammates here. Okay, all right. All right, let me just promote one of my teammates to the panelist. Okay, great, great. And let me see. Wonderful. All right. If you're already seeing in my lab that your account is active, then that should be good enough. Most of the people who take the course with us, they generally get the activated account. Okay. Um, a question is, in this session, are you going to dive into mathematics powering TensorFlow? No, we are not going to. Okay. A question from Kevin. I have signed up for the lab. How long will it take to allow me to open Jupyter? It should not, it should take maybe like 10 minutes in the entire process. Okay. All right. Great, great. All right. So we're going to um, okay, let's go ahead with the rest of the session. All right. So what we're going to do is we are going to understand the deep learning and the machine learning with the real use case. Okay, with the real use case. All right. So how many of you have played Mario before? Yes, you can respond using the chat or okay. So probably everyone here would have played Mario before. Now, my question to all of you is, how much time did it take you to learn and win the prizes? Now, that is something not everybody would have done. Okay. So now my further question to all of you is, did anyone teach you? Did anyone teach you how to play Mario? No, right? Now, next question to all of you is, can can the computer learn by itself playing Mario just like you did? Just like all you did was pressing the keys and observing whether the score is going up or down, and then figuring out, looking at the screen, that what's going on there, this is where you failed last time, this is where you lost the score, and so on. Can the computer do the same thing? Can the computer learn any game just by observing the score or aiming for the score and observing what's there on the screen? So this is exactly what is machine learning, and deep learning is one of the ways of solving it. All right. So here is what the setup is about. The program learns to play Mario. How? It observes the game. It observes the game and presses the keys and maximizes the score. Okay. And how did it observe the game? How did it observe the game? The way it observed the game was basically this program that is Mario. The Mario game is basically run inside the simulator. There are simulators which can run the game or any NES game. And then once you have a simulator in which it is running, then your program can inspect the simulator, the memory of the simulator. All right. So this screen that you see here is essentially a space in the memory in which the data would be kept. So if you, by the way of program, if you can just pick that memory region in which the score is kept, and you can pick the entire screen where the data is kept and where the screen is kept, then you can automate the learning. Okay. So, so the way it was automated is, again, the program hooked to the simulator, kept on observing the screen, and 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 tried to try to maximize the score and pressing the keys. All right. So let's take a look at how did it go. All right. So what you see here is the day zero of Mario learning. You can see this is like an infant where the Mario is just jumping, going nowhere and dying of old age. Couple of more days and it looks little better. For no reason it's facing backwards and it just has started to move. They started to move, but it is badly stuck on these hurdles. Few more weeks of learning and then it starts to kind of learn better than myself. So you can see that the it's able to do simple things, but again it is not really there yet. Okay. So will it cross? Yes. Okay, so so as you go ahead, now the Mario is not having a problem at all. It's just going good. Few more weeks of practice and the program is an expert at Mario. You can see that. Now you're going to observe something really wonderful. You're going to observe the program exploiting the bug in the game. What you just saw, what was that? What was that? So the Goomba is falling on it, and the moment it's falling, it just starts moving down a slide, down slightly, and that's how it scores. So you're going to see one more the program exploiting one more bug. You're going to see that. You see that? I have no idea how did he do that. He was about to fall and then recovered. So again, some games it is not able to perform well, and in those games, it was starting to pause the game. All right. So what we just saw was that the program learned to play Mario and even learned to exploit the the bug in the game. It figured out the bugs that we have never seen, the bugs that we have never exploited, and so that basically gives you an idea about the advantages of machine learning, right? So, and in the end, it was able to do things like human, right? In the childhood, when our cousins were not able to win, or our siblings were not able to win against myself, they were used to spoil the game. In the same way, it was pausing the game again and again when it was not able to win the game. So basically the idea is that if the program or the machine learns by itself, the kind of results going to be there are going to be really wonderful. Okay, so so basically the program learned to play Mario and other games without programming. Now, question to all of you, you can respond using the chat window, not Q&A window. To make this program learn any other games, such as Pac-Man, we will have to write new rules as per the new game, or just hook it to the new game and let it play for a while. That's right. So you just hook it to the new game um, and let it play for a while. Let it learn from the game, and the program will become an expert at it. All right. So correct. So as long as there is a score counter, it will do good. All right. So, okay, a question at this point is that's something I feel that it should be answered. Was it programmed to pause when it's going to lose? No. It just figured out that that's the only way, that's the only way to that's the only way to retain the score, because it was supposed to maximize the score. So it figured out that the only way it could retain the score was to keep on pausing it. Okay, because it could not win the game, and therefore, all right. So what we just learned was uh, a machine learning to play game that we think that requires a lot of reasoning, a lot of intelligence, and lot of observation, right? So now imagine doing the same thing for life, gathering data, and automatically solve problems. So why was Mario able to do, or why was the program able to play the game so efficiently, such as Mario? Because it has access to the data. It has access to the data. It is able to basically play the game again and again and generate this data, this information about all the kind of failures, and it is able to generate the data on the fly, and therefore it's able to play Mario efficiently. If we could do the same thing for life, and we should be able to solve many problems automatically. So you can think of ourselves in this environment just like we saw Mario in that 2D environment, and here just the dimensions are more, and so on. All right. So now, on the same principle, there is kind of a tsunami. There are all kinds of things that are happening now. Why are they happening now? Because the algorithms are available. The 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 computer processing has improved manifold, and the data is being gathered efficiently. So So the example of Mario that we saw is under a term called reinforcement learning. We'll discuss that. There is a project in this course on the same, uh, in which we will try to simulate the same behavior as the one that we just showed you, that we will try to learn a game. We'll write a program that will learn a game and do that as part of this course. Now, there are self-driving cars on the roads as of today. The self-driving cars also basically function on machine learning, and deep learning is just one part of the overall machine learning. Now, the self-driving cars on the road basically, uh, you gather a lot of data and they drive a lot of insights from the data. Data could be the pictures of the road. Data could be the the infrared signals from the road, and data could be the other GPS location and so on, right? And okay, now the other example that are not so obvious where the machine learning or deep learning is used is Netflix, for example, the movie recommendation. So it's part of the machine learning. The next one is the Amazon's product recommendation. Again, there is a use of deep learning and machine learning. Similarly, the accurate results in Google search are basically done using the deep learning. Okay. The speech recognition in your smartphone is also a part of deep learning. So when you say something and it recognizes the text, it is deep learning. Next is, okay, so what we learned from Mario example is that we need data and we need intelligence. Intelligence as in algorithm or ability to solve problems given the data. So data and intelligence, to get the data, we have the process like collect, clean, and process. For collecting the data, we use all kinds of IoT devices. On one hand, the 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 data is being gathered as of now at a very high scale. So on one hand, you have devices and sensors that have become cheaper, faster, and smaller. On the other hand, the connectivity has improved. That's why that's why collecting data is very much possible now. So then comes the cleaning and processing part. For cleaning and processing part, you need the computing power, and for that you need generally a distributed system. And what does it mean by a distributed system? Distributed system means many computers connected together to solve a single problem at a time or multiple problems. Okay, but the problem must use more than one computer. So if you can break down a problem into into parts that can be run on different computers. We call it distributed computing. Distributed computing is part of parallel computing. And when we are having so much of data, then it's better to use distributed computing to clean up the data, to process the data, and then to drive the intelligence. Okay. Okay, so the machine learning and deep learning are the same in the sense that machine learning basically is a larger topic, while deep learning is a part of machine learning. Deep learning is part of machine learning, and deep learning is specifically with respect to the neural networks. The design where algorithm that we are going to use, those are based on the animal mind. So though that is called the deep learning. So deep learning is part of machine learning. The objective is same. It's just the way the algorithm is designed, it's just different. So deep learning is part of machine learning. Okay. So essentially so one part of the parallel computing is distributed when we want to process data, as we talked about here. So after collecting, we need to do the cleaning and the processing. For cleaning and processing, we need massive amount of computing. To do that, we would need either a distributed system or a parallel system, as in the GPU-based system. Basically, you have many processors in the same computer. That's called either the multi-core or GPU, though they are different, two different things. In case of multi-core, you have 1, 2, 3, 4 cores. But in case of GPU, you have hundreds of cores in the same machine. Okay, hundreds of processors in the same machines. That's why they're able to do a lot of processing really fast. Okay, all right. So after this, I'm going to just give you a walkthrough of how does Jupyter and the hands-on would look like, so that you can get ready. And some of you are still getting confused between the interface. So I'll just give you a overview just after this. All right. So we talked about three kind of computing. So for processing the data, you need three kind of you have different kind of computing, and one is multi-core, like the dual core, quad core, the normal computers that you have, that's multi-core. Then we have GPU, which is general purpose graphical processing unit. These were the units that we used for playing the games, right? And basically the same, these computers which have GPUs, they were they were very specially designed for doing the mathematical operation. And you need mathematical operation both in the deep learning or machine learning, as well as in the you need the GPU in the so you need GPU in the graphics based programs, because there is a lot of mathematical computing required. Similarly, you need this in deep learning or machine learning. Okay, the third one is distributed. When you have a lot of data and the disk speed is really the bottleneck, then you generally need a distributed system. So so here is a differentiation. If you want to handle huge data, which means that it is going to read data from disks, then distributed computing is the way to go. If you need really fast communication between various processing units, then you either use multi-core or GPGPU. Okay, we simply call it GPU instead of calling it GPGPU. Also, if you need a computer for good maths and graphics, then you generally go for multi-core or GPU. Now, the kind of tools that we use is um, if you if you need to if you need to just utilize your multi-core, you can use the the Hadoop, Spark, or any other libraries, or if you are going with GPU and you want to do a lot of computation related to machine learning, you might require a library like Keras, TensorFlow, Caffe, and Spark. In case if you need to do the distributed computing, then you have Hadoop and Spark. And also now TensorFlow also has a distributed version. We will be learning the distributed part of the TensorFlow in this course. All right. So, and before I jump into this comparison between traditional and deep learning approaches, I would like to I would like to show you how does it look like. So if you have enrolled successfully and you go to CloudxLab, right? Then if you go to CloudxLab, if you're enrolled successfully, you will see My Lab. Inside My Lab, you will see the login and the password, and you can click on Jupyter. For me, Jupyter has already logged in. Okay, so I can log out here just to show you that how to log in. And when you click on Jupyter and you're prompted with login password, just copy this and paste it here. Okay, copy this and paste it here. Okay, these are the login passwords. These are the login passwords for logging into Jupyter. All right, so this is how it looks like. So the other part is, in case you have not, you don't see My Lab when you go to CloudX Lab, you could also just go to cloudxlab.com. Okay, if you don't see My Lab here, if you don't see My Lab here and you see a screen like this and you can't log in, so you can just click on free trial. Okay, and sign up with Google, and this is the first step. Okay, so I could just sign up with Google and provide login password, and then it'll ask you, it'll take you to the KYC, as in know your customer wizard, where you have to provide, you might have to sign up using a Stripe and just pay for $1, and that'll be refunded soon. This is required. Why do we need KYC? So that it's kind of a recommendation from the legal team. The idea is that since we are giving the entire infrastructure, then we must know our user, because there is a lot of things that could happen on the lab, right? So it's better to know the user, and by knowing the user, it doesn't mean that we'll be knowing your credit card, but we'll just know that you are somebody who has made $1 kind of payment with this type. So that is kind of a standard way of providing the cloud infrastructure, whereby whereby we must know a bit about the user. So okay, so that's why, because there could be denial of services. So if that could spoil the experiences of the other users. All right. So therefore we have this KYC process. All right. So that's how it is. So once you have signed up, you might receive an email. Okay, and so on. Great. All right. So there are a few questions. I'll just go over the few questions. All right. A question from Guru is, I'm a beginner. Could you please give an overview of how these things are different? Automation. Automation is any computing is automation. Business intelligence. Business intelligence is observing data and giving the insights. Okay. That's basically a static process whereby we'll go through the data and give the insights. Now, data modeling. Data modeling is part of business insights, whereby given the data, we prepare the models. I'm just answering a question. Algorithm. Algorithm is set of steps which are part of automation, which are part of business intelligence, which is part of data modeling. So everything at the end of day is an algorithm. Okay, so there are some algorithms written for machine learning. There are simple algorithms to do everything. Okay, So everything at the end of day is an algorithm. All right. So machine learning is basically the act of machine learning by itself by observing data. But we will have to feed the data. We'll have to tell machine that this is the program to use, the way to learn it, and so on. AI is trying to create human-like behavior in the machines. Okay, trying to create human-like behavior in the machines is AI, and how to achieve it? Using machine learning, using automation, using other aspects. Okay, so AI is something like an objective-driven definition, and the machine learning is a technique to achieve the AI. Okay, automation, algorithm, machine learning, all of these are techniques to achieve AI. All right. So I hope I was able to answer your question. Um, a question from Priyanka is that this video game playing comes under unsupervised learning, right? This is an example of reinforcement learning. We'll talk about it soon. Okay. Uh, Question from Sambo is, it means that we don't have historical data, then difficult to write ML. Correct. If you don't have data, then it's difficult to write machine learning, right? So even though what we can do today, it's a good question from Sambu. Question is, if we don't have data, can't we use ML? We do use ML, machine learning from time to time. And what do we do in these cases is we use the third-party APIs. Say, for example, Google has voice API, right? So what Google has done is Google has built this engine of converting the voice to text. Okay. Now, they have a lot of data, so they were able to do that. The same thing could be done, could be utilized by you by using their API. All right. A question from Sambunath. If I'm not wrong, ML and deep learning are same. Yes. So deep learning is just one part of machine learning. Machine learning is a larger subject of computer science. Okay. A question from Guru. For deep learning, we need data. So can we just use AWS service to ETL and store the data, or do we need to learn big data tech stack like Hadoop, Scala, and Spark? So basically, yes, you could use the AWS services to do the ETL. You there are alternatives to Hadoop, Scala, Spark, but as part of if you are learning for Spark, say learning Spark or Hadoop, the idea is that you would learn how to do distributed computing. You cannot do distributed computing just by using framework. You will have to divide the program into logical units, which can run parallelly on multiple machines. Therefore, therefore, it will be important to learn how to convert your work into something that can be distributed. Okay. All right, what is the role of data science in deep learning? Anywhere, wherever you have deep learning or machine learning, you need data to train the computer, and to reach to data that could be fed to the algorithms. We need to do a lot of churning, a lot of processing, a lot of messaging of the data, and that's where the data science lies. Okay. Uh, question from Niranjan. Is it possible to derive data from requirements and make data and apply it ML? It is not possible to manufacture data, right? Because at the end of it, we want to learn, we want to create algorithm. Okay, so basically, if you mean that making data like the way we did in case of Mario, we just let the program play Mario by itself. That is kind of making data, right? So that kind of making data is possible, and that should be done. Okay. A question from Pratik is, the biggest example of reinforcement learning is AlphaGo or AlphaGo. Okay. So yeah. So that was another example of deep learning where the program was playing against itself and was training against itself. Yes. All right. So, all right. Great. Great. So I'm going to walk you through this particular example and then we'll answer your question again. One more thing, I forgot to show you the Jupyter part. So I hope that was good enough, right? The one I showed you. So you go to CloudxLab. All right. So let me just show you if we have this. If you go to CloudxLab, then once you have signed up and enrolled, you will see My Lab here. And then you can click on Jupyter. And Jupyter will ask you for login password. Here you will see login password. Just copy paste these login password there. This will be asking only for the first time. And then once you're done, you can click on start server. You will see a big button saying start server. And then you can click on new Python. Okay. So this is the Python notebook. And this is where we will be writing our program. So this is a simple Python notebook. In this, we can do a TensorFlow here, import TensorFlow. So yes, okay. It gives some warning, but you can go ahead. Okay, that's okay. All right, so that's how you get started with CloudxLab. All right, great. So I'll try to take questions after say 15-20 minutes so that we can discuss things in more details. All right, so we've talked about these parts. Where were we? How did we jump back? All right. So we were discussing about classical difference, standard difference between the traditional versus deep learning approaches. Say, for example, you want to write a spam filter. Say your task is to write a spam filter, maybe for emails, maybe for SMS, for example, and your job is to figure out how to build the most efficient spam filter. What is a spam filter? It separates between two kinds of emails. One which is meaning useful emails, other which are just spam, as in which are just bulk emails. And how do you write a spam filter? Okay, so spam or ham. Ham is something opposite of spam. So this was the traditional approach where we would study the problem, we would write the rules, and then we would evaluate the the rules, and then analyze the errors, and again study the problem more, and then again add more rules, and then evaluate. If it is giving good results, then we launch. Otherwise we do not launch. Okay, otherwise we do not launch. Okay, so All right. So what problems do you see in this approach? What problems do you see in this approach? You can respond using the chat window. Correct. Correct. So we can't write all possible rules, and you are limited by what rules we have written, right? So one, the problem is not trivial. The list of rules could go really lengthy, and and at the end of the day, you will have this long list of complex rules, and which will be pretty hard to maintain. And once spammers notice that you have basically tagged for you as blocked. You're blocking for you as per one of the rules. You have created one of the rules which says that the emails containing for you should be blocked. And if spammers notice that, they will write FOR space U instead of numeric for you. So the moment this starts happening, the moment spammers notice that, figure out that these are the things you're blocking, they will create new workarounds, and they will, and in the end, you will keep writing new rules forever. So the machine learning approach is, or deep learning approach is, that you study the problem, you train the ML algorithm, and then evaluate a solution, and then if the solution is good, you launch it. Otherwise, if it's not good, then you analyze the errors and then again study a bit of problem, then train the ML algorithm, train the algorithm further on the data, and then do the cycle again. So the difference here is, instead of writing rules, you are training algorithm to come up with the rules. So algorithm is coming up with the rules given the data. You have the data in which you have marked that these records are spam, these emails are spam, these are not spam. And what we want to do is we want the algorithm to study the data and come up with rules by itself. Okay, a question could be at this point that how would spammer know that their mail went to target a spam box instead of a inbox? They could also create their own inbox in your server and start sending the spam to their own inbox and observe the behavior of your spam filter. Okay, so there are many ways to understand the system, because if your system is public, right? Now, so I hope that this gets the approach clear. The deep learning approach, the deep learning approach is a spam filter based on machine learning technique automatically learns which words and phrases are good predictors of spam. By detecting unusually frequent patterns of the words, the program will be much shorter, will be easier to maintain, and most likely more accurate than traditional approach. All right. So here is a further enhancement to the same approach. Here is a further enhancement to the same approach. The word for you has become unusually frequent in spam flagged by the users, right? So let's say you came up with for you, and it starts flagging them without our intervention. So basically, the machine learning approach is that it'll keep on updating data, training algorithm, and this portion of deploying and updating data could be automated. This is part of the real-time machine learning. Okay, so basically, the we here at this point, so this portion where where the updation of data is happening. We are training the ML algorithm, we are evaluating solution, and then launching. This portion could be, this section of the cycle could be automated. And when you do this automation, then the entire system will keep on running by itself. Now, at this point of time, there could be a case that what if they poison this data? What if the spammers poison this data? This is where your training ML algorithm would have to depend. As in, it needs to, we'll study this part that if you observe too many outliers at this point, you might have to stop this automated process. Okay? Okay. So a question is, now, Now, other than coming up with this approach, other than coming up with the solutions, what else can machine learning or deep learning approach teach us? It can help us learn that, so we can inspect the algorithms, what they have learned, right? Spam filter, after doing enough training would reveal to us that what words that it believes are best predictors of spam. It may reveal unsuspected correlation or a new trend. It leads to a better understanding of the problem for humans, and therefore we can learn about spam more if we have a better machine learning algorithms. Okay, so a lot of machine learning algorithms are also used for the clear understanding of problems, as in what characteristics of the data is more significant than the other, and so on. That is also part of machine learning. All right. So, all right. Great. Great. Any questions at this point? Okay. Do you want me to go over the classification of machine learning? All right. Okay. So I think I have those slides, but I had removed it for this discussion. Okay. All right. So I'll just give you an overview, a very quick overview of machine learning classification, and then we'll start with that work. All right. So machine learning generally is divided into three large buckets. One is human supervision, but one is based on whether we need to provide supervision or not. Second is we want to learn incrementally, as in we want to just learn a few more things based on what we have learned in past. Third is how well our algorithms generalize. Okay, so various machine learning techniques are classified based on these three criteria. Based on human supervision, we have three kinds of machine learning. One is supervised, unsupervised, and reinforcement. Okay, so supervised means the supervised machine learning is the one where we learn where the okay, so supervised machine learning is the one in which we uh, basically have the data. We have the data with clear demarcation of what is right and what is wrong. So we already have the definition. We already have like a teacher for the machine algorithm. So in those cases, we generally call it supervised learning. Supervised learning is the classic case, and supervised learning is the one where we have already the historical data with clearly marked output. We know that for this, this was the output, for this was the output, and so on. So we have kind of a training set. Okay, so the supervised is further classified into classification and regression. In supervised, there could be two situations. One in which we would like to just label things. When the so if we would feed the algorithm and we would desire solutions in the form of labels, and this is called classification algorithm. So spam filter, it was an example of classification. Okay, while in case of regression, the other kind of supervised learning, in case of regression, we have a new instance. Okay, we need to predict a value as opposed to just a label. We have to predict a value as opposed to just a label. Okay, so it just as opposed to a discrete label, we are predicting a decimal value, a particular a number value, or a character, or some other value. Okay, so instead of just labeling, so this is called regression. Okay, say for example, we want to predict the price of the car based on the features of the car, then we call it regression. Okay, then the other part is unsupervised learning. So supervised learning is the one in which we have the training data available, and we know clearly that this data is uh, is labeled like this, or this data, the outcome is this. That is called supervised learning. The unsupervised learning is the one where you don't have labeled data, you have unlabeled data, and the objectives in supervised learnings are different. In the supervised learning, we kind of try to either do the clustering, or do the do the hierarchy creation. So let's say here we are trying to, given this group of users, we want to given these users, we want to kind of separate them into groups based on certain measure of the distance. That certain measure of distance is something we need to define. We need to tell what is the basis for similarity between the user, and the system would automatically cluster them. Okay, so there could be many examples of clustering, like for example, detecting group of similar visitors in a blog, and notice the training set, and notice the training set is unlabeled. So this is basically an example of clustering. Okay, so to train the model, as in to cluster the data, we feed the training set to the clustering algorithm. At no point we tell the algorithm which group a visitor belongs to. This is called clustering, and you may come up with very wonderful insights out of clustering. Okay. Now the other one could be, the other unsupervised learning is hierarchical clustering. All right. Hierarchical clustering is an interesting one, whereby we bring similar elements together. We bring the similar elements together in the form of tree. Okay. The nodes that are close to each other are similar. Like for example, if you see the classification, as in the species classification, you will see that the humans and chimpanzees are together here. Okay, and monkeys are a little bit far, and then mouse and rat are similar, but they are far away from human and monkeys, and dog and horse are similar, but they are again far away from this. So what you see here is that the given these animals given their all characteristics, all hundreds of thousands of characteristics, how can I come up with a hierarchy? That is the kind of task that we need to do in machine learning. Given, say, objects, given users, given cars, given any kind of objects or things or records, with the features, with their characteristics, we need to come up with a hierarchy. That's called hierarchical clustering. So, all right. So the other example could be in case of detecting unusual credit card transaction to prevent fraud. Okay, say you want to detect the unusual activity in an account, then that can also be part of unsupervised learning. Okay, the third part is reinforcement learning. So we will do these supervised, unsupervised, and reinforcement in both. In we have done that part as machine learning, the classical machine learning. Now we will be doing the same thing as part of the deep learning. We will be learning how to do supervised, we'll be learning how to do unsupervised using various techniques in deep learning, and we'll also be learning how to do reinforcement learning. What is reinforcement learning? Reinforcement learning is that we have, and just like in Mario, the way we have Mario, so we have an environment. The player, the actor, can do various actions, and there is a reward and punishment. So reinforcement learning is more like continuous supervised learning. Okay, or you can say instantaneous supervised learning. You take a step and it gives you punishment. If you do some action, you get reward. Okay, so that kind of environment is generally there in reinforcement learning. It could be a very simple. The example we are going to do as part of this course in reinforcement learning is based on the classic example of um, let's say you have a cart and there is something standing on it, and you have to balance the pole on a cart by moving the cart. You have to balance the pole standing on the cart. Okay, if the pole is falling to the right, you have to move the cart to the right. If the pole is falling to the left, you have to move the cart to the left. So we will be using a simulated environment for that will be, you have to just move the cart back and forth in order to balance the pole. That would be one of the cases in case of reinforcement learning that we'll be taking. That's a toy example, but it is a very good representative of what we do. All right. So the that is reinforcement learning, where there is a game or environment where we need to take some actions and we get reward or punishment. All right. The okay. So the other kind of classification of machine learning is based on whether we learn incrementally or not. So the example in case of if you want to learn incrementally, okay. So if your algorithm needs to keep on learning incrementally, as in when new changes are occurring, it is learning by itself and updating algorithm, that's called online. If you are basically running it periodically on the entire data, that is called batch processing. Batch processing, you train every time on the entire data set, while in case of online learning, you train basically on partial data. Okay, whatever new data is coming. So, and the second classification criteria was how well the algorithms generalize. Okay, how well they generalize, as in, do they look at an instance and then they go through the history and then they give the results, or do they do the real predictions by giving average? So how well the algorithms generalize, that is another way of classifying the machine learning. Okay, there are two kinds of examples. Let me just show you that part. Okay, right. So let me just, I have a better example. Okay, all right, never mind. So I can just explain it in very simple words. Okay, so yeah, all right, let me just go back where we were. Okay, The third criteria was whether the whether we are okay, so whether the learning is instance based or model based. So there are two ways to look at the learning. One is model based and instance based. Instance based is the one where you map an input instance to an existing instances and then find out what is the nearest closest match. That's kind of a searching, and that is also called machine learning in parts. And the other way is that you prepare a model by learning and then let the model do the prediction. Okay, that's model based and instance based learning. So those were the forms of learning. Now, moving ahead, so I just took you through a quick overview of various machine learning kinds. We talked about supervised learning, unsupervised learning, the batch learning, online learning, and reinforcement learning, and instance-based and the model-based. Okay. All right. Now, this is an example of what we learned. Now, the next part is understanding the artificial neural network. So, the classic machine learning based on statistics and other algorithms was was there since 1950s. Okay, since 1950s or even before that, a lot of work was done on machine learning and AI. And there were many languages invented, there were many systems invented, there were many rule-based systems created in order to achieve AI or machine learning, right? In order to achieve AI, a lot of systems were created in past. Now, most of these systems were doing good, but they were not able to achieve a very high efficiency. So one of the breakthrough that happened in 2006 was the in 2006, one of the breakthrough that happened was proof that the artificial neural network is actually powerful enough to solve the problems. Though the idea of neural network has been there since 1970s, in which there was an idea of modeling the algorithm based on the animal's brain. It was there, but the proof that it is actually able to solve practical problems happened in 2006 when a couple of algorithms were invented. Okay, so what is artificial neural network? Artificial neural network is computing systems inspired by biological neural networks that constitute human animal brains. Okay, so instead of writing the statistics based or other normal programs, the standard algorithm that have been there, one of the algorithm came up as that let's create the animal brains and then see whether they are able to perform or not. And that was called the the algorithm based on artificial neural network. So in this, what we do is we create these various layers of neurons, and we'll talk about neurons, what it is, and then so what we'll do is we learn progressively to improve performance, to do tasks by considering examples, and generally without task specific programming. For example, based on image, we have to predict cat or dog, okay, or cat or not a cat. So those are the examples in which we can use. So here, this is an example of artificial neural network. So there's an input layer. This is where we feed the data, like the way humans feed the data here. All the senses are feeding the data here. And here it's converting them. And then there is another layer, which is basically um, learning it, and then basically is going to learn it. And then there is output layer. Output layer is something that we have. This is where the output is generated. Now, at the training time, based on the outputs, we tweak these weights of each of the neurons. Here, this is called a neuron, and that basically I'll explain neuron in a better, simple way. All right. So the easiest way I can describe a neuron is by this example. Okay. Let's say you have a knob. This is your knob. Okay. And there is a hot water and cold water going into the knob. Like this is the challenge every day we face while taking bath. And so this knob basically based on how much temperature we want, there is how much temperature in terms of our comfort level, not absolute. Okay, how much temperature we want, we keep on tweaking this knob. Oh, it's too hot, so let's just rotate it to the right. Oh, it's too hot, too cold, rotate it to the left. So here, this neuron, this knob is what we adjust based on the output. Based on the output, we are adjusting the knob, and the input is being fed to the knob. Okay, so that's exactly what individual neurons in the human brains or animal brain does. It gets two signals, and based on the expected output, it tweaks itself. It changes the knob. It changes the coefficient of how much the left should go, how much right should go, and that's exactly the role of neuron. So the human brain is made up of millions and billions of neurons, and the individual knob individual knob is actually a very simple uh, individual neurons in the human brain, which has many neurons. Individual neuron is actually a very simple unit. Individual neuron is a very dumb unit. Okay, all it does is, based on the output during training, it basically keeps on tweaking this knob. Okay, it keeps on adjusting the weight it needs to give to the left and to the right. It just keeps on changing that based on the output needed. This is called neuron based learning. So individual neuron is essentially a very simplistic unit. Now, think about it. Think about it. This particular neuron is adjusting the temperature. There could be there could be another knob. Okay, there could be another similar knob that could be adjusting the pH value of the two input chemicals, right? And then there could be another similar knob which could be adjusting colors between various could be adjusting the colors. Let's say there is a red or black and white from the left and right, so the knob is basically picking up some black, some red, some black, some white. Or the inputs could be another neuron which is basically selecting from red and green and so on. So using many layers of neurons one top of another, such kind of thing. So again, let me just describe again. So imagine that here we have one knob that is adjusting hot water and cold water, and we are getting some water like this. Okay, and then there is another knob which is adjusting between the acidic water and basic water, like the pH value, right? The third one, there could be another knob. There could be another knob that is adjusting between black and white, the color. There could be another um, another another knob that could be adjusting between, say, the red color and green color. Okay, so this way when you have these many knobs parallelly, when you have these many parallel knobs, you could basically further set down another set of knobs which will take the input from this. Okay, and then whatever is your desired output, based on that you could iterate through all possible numbers and set the individual value of each task, each knob, right? you could you could set the value of each knob. There are many such knobs, and that's how you could achieve creating any chemical just by using this technique. So theoretically, this is very much possible, and that's what the deep learning does. In case of deep learning, we create these simplistic program or simplistic mathematical units. Okay, okay, it's a simplistic unit, and it could be considered like based on linear algebra or based on just very simple maths. Okay, and and that's what is the core idea behind the deep learning. So all you see is there's one neuron here, another here, and so on. They are taking inputs and they are tweaking the input in order to give some kind of output. Here it's giving multiple outputs. Now similarly, there is a this is a simple neural network. Okay, so this is a simple neural network. Okay, and this is a little complex neural network. So simple neural networks, and this is generally called deep learning neural networks. What does it mean by deep learning neural networks? In deep learning neural networks, you generally have this middle layer. This is called a hidden layer. This middle layer is, there are many more hidden layers. Okay, in case of deep learning neural networks. So this is where the term deep learning comes, because it has multiple layers of learning. Okay, so essentially, though these individual units are extremely simplistic, they are very simple knobs, but when you put them together like in this kind of conjunction, the outcome is really good. And what does it mean by model, or what does it mean by learning? Meaning of learning or model is the the learning of their knobs, the coefficients, we call them. Okay. So yes, when you have more than one hidden layer, then we call it deep learning. Okay, when you have more than one hidden layer, then we call it deep learning. All right. So who is using deep learning? Almost everybody is using deep learning as of today. They are using deep learning in one form or the another. So BuzzFeed is using, Optimizely is using, Airbnb, Google Photos, and so on. All right. And in the same way, you must have already tried auto draw from Google and the Google Voice, Google Translate. All of these are using. Okay, here is an example of a demo of a playground from Google. You may want to give it a try. Okay, so all right. So there are a few questions. Let me just answer those questions and then we will move ahead. And okay, there are questions from Kiran. Questions from Kiran is, how do you prevent overfitting or underfitting of data? The overfitting versus underfitting is the holy grail of machine learning. Most of the algorithms basically try to avoid overfitting as well as avoid the underfitting. Underfitting is also called bias, and overfitting is also called mm, um, variance. So if you have too much of, so okay, those who are new to this world, of machine learning, let me give you an answer of this one. What is underfitting and overfitting? Underfitting is going to an exam just knowing, let's say you're going to an exam and it's a complex exam and you have just learned one particular chapter or two particular chapters. Okay, basically you've learned the basics of maths and you think that you can solve all kinds of problems in the exam. So you learned the basics of maths and you think that you can solve all questions. So that's basically underfitting. You you are you are having a very simple model. Okay, and with that model you want to solve or predict the answers for every question. That's basically the underfitting. Overfitting is that you memorized all the answers to all the sum in your maths book, okay, and going to the class. So instead of learning maths, what you did was you memorized all the sums. Okay, that's basically overfitting. Instead of coming up with a model that there is an understanding of the maths, you basically memorized all the sums. So when you see a sum which is not similar to what you have learned already, then your answers may not be correct. So in both the cases, whether overfitting, whether you mugged everything or you did not mug anything, in both the cases the performance will be bad. And in case of overfitting, the difference is, if I mugged from a book, if you ask the questions from the same book, I'm going to give you the correct answer. But if the questions are from different book, are different and questions are different, the overfitting fails. Okay, so overfitting is memorizing everything, and the underfitting is just considering it very looking at the maths and considering it is a very simplistic way, considering it like only sums can solve everything. Okay, so that way, so underfitting and overfitting is very, very difficult problem to solve, and probably every algorithm, regularization, many ways we try to solve that. Okay, there are almost every algorithm we do the fine tuning in order to avoid underfitting versus and the overfitting. So we call it bias versus variance trade-off also as a term. Good. All right. So I hope I was able to make sense of underfitting and overfitting. Question from Pratik. Will we need any sort of feature engineering in deep learning? And of course, you would need that. You would need to use the techniques of cleaning data, updating data, and so on, but not too much of feature engineering, as in introducing new features and all. Those kind of things are very well inferred in deep learning. Okay, so I would say that, in other words, that here you would need to do a little less feature engineering, but the classic imputer, the cleaning up data and everything would happen by itself. A question from Siva: Wouldn't wouldn't this lot of data put a restriction on amount of learning that can be done? So yes, it does put a lot of restriction. If you have a lot of data, that basically, if you have a lot of data, you generally get better results. But the limitation comes from the hardware, computers, as well as algorithms to process the data, and therefore there is always the the size of the data becomes a problem. Okay, a question from Sambu. Can you explain about training model? I mean, does this work? Sure, we'll take this as part of the course. All right. All right. Next is a question from Amandeep. Helicopter project by Andrew Ng is an example of reinforcement learning. I've not looked into that. I will take a look at which one is the helicopter project. Okay. So I think you must have got it by now. What does it mean by the reinforcement learning? Okay. So question from Sergio: what is the math used by these knobs? Is it based on linear algebra? Yes, based on simple linear algebra. Okay, specifically the regression. Okay, a question is, okay, and a question from George is, when a simple, okay, this I think I've answered. Question from Sambhu is, how do I know hidden layer? Okay, because you will have, we be constructing the neural net. Okay, that's how. Okay, so while we'll construct these individual units, put them in layer, and then assemble these layers as part of the deep learning, and therefore you would know when you're using one. Okay, so a question is from Malikram: will NLP help machine learning? It's the other way. Machine learning would help NLP. NLP is an objective-driven exercise where we do the natural language processing. In natural language processing, there are various tasks given a sentence, just like human does. Given a sentence, understand what does a sentence mean. Okay, and there are many more tasks there. One is called recognizing individual entities in the text. Other is there are many tasks that are there as part of NLP. Okay, just like humans do. And given a news, we should be able to summarize the news and so on. And those are all part of natural language processing. So those are actually solved using machine learning. And there are many techniques available in NLP. Okay, so it's the other way around. Deep learning helps deep learning as well as deep learning and hence machine learning help in solving natural language processing tasks. Okay, so all right. So a question from Kiran is, why shouldn't everything be reinforcement learning like AlphaZero, reading the newspaper? Okay, so yeah, we've learned that part, how to differentiate between the problem statements. Okay, so because in case of AlphaZero, it was basically given an environment where the algorithm could play against itself. Okay, so that therefore you did not need external world's data, and it was able to train itself. um, so we are talking about AlphaGo, right? Here, so I'm not sure. um, okay, so like in AlphaGo, we had the environment. Basically Google had the environment, and it was learning by against itself by playing a move and observing whether he lost, the algorithm lost or won. Okay, whether it lost or won. Okay, a question from Rahul: if we see the tap example, how can we relate it to the simple neural network diagram? So the individual tap is like the neural network here, like the neural net. Here you see this here, the blue colored one. This is basically you can think of it like the knob. Okay, there are inputs coming to it, and it's giving a single output. Okay, all right, that's how. So there are many knobs, 1, 2, 3, 4, and so on. There are so many knobs around, and that's how you can think of it. Okay, so we are tweaking these knobs. We're tweaking these knobs. This knob basically controls so many variables. Okay, and we're tweaking this knob so that we get the expected output. All right. Do we use deep learning for NLP? Yes. Why can't everything be like AlphaZero? There's no silver bullet in simple words. Okay. Okay. Thank you, Pratik. AlphaZero is a better version of AlphaGo. Okay. Good. Great. And Ajay's question is, we can say that we need to understand basics of ML to learn deep learning. Yes, basics of ML would be required for this course. And if needed, those basics of ML, we can keep a separate session and we can go over those separate session in which we can cover like what is overfitting, underfitting, and things like that. Okay. A question from Malikram: can we write AI algorithms in Python, or is there any specific language? Okay, this is the one point I would like to make it very clear to all of us that in today's time, you are not limited by the language. Same program can be done in R, Python. You could also do it in Java. You could also do it in Scala, and so on. As of today, all the languages are interoperable. All the languages are interoperable, and that interoperability, the performance drop by interoperability is something that frameworks like TensorFlow also solve. We'll talk about this part. So do not worry about a specific language, just that uh, learning a language could be really easy. Like if you're learning, say, Python, it could be really quick. That's one of the reasons why Python has got the adoption, as well as it's quite easy to get started and it's quite powerful. So in this course, we are going to go with Python, but same concepts, same ideas can be done using any other language. All right. So TensorFlow is available in R and in other languages. Okay. All right. Okay. So I think I mistakenly marked somebody's question answered. Okay. A question from Amandeep is data pre-processing versus feature engineering. So the feature engineering is you add more features, you remove certain features. That is called feature engineering, like or dimensionality reduction, or let's say you infer some feature which is a derived feature which makes more sense. That that is a part of feature engineering. While data pre-processing is like filling the missing values, or filling the missing values, or standardizing the values, and so on, or cleaning up the data, creating the features. That is called the data pre-processing. And feature engineering is about figuring out if we need more features or we need to drop some features. Okay. Can you state prerequisites, choices available, and resources for every stage of deep learning? So in deep learning, so I hope you are asking the question with respect to the course. So can you state prerequisites, choices available, and resources for every stage? So we'll talk about this towards the end after this. A question from Anik, please. We can, yeah, just give me some like 30 more minutes and then we'll start. Okay. All right, I would love to give that answer. I think that doubt will get cleared after some time. Okay, how can we handle imbalanced data set in ANN? We will learn that part as we go ahead. Okay, question is, can you please explain how to understand parameters like W and B for a sigmoid function with a real example? Sure, we'll do that as part of the session. Okay. A question from Chandrasekhar is volume of the data, diversity of data, which one is more important for deep learning? Okay. Um, yeah, so that's basically a standard question, basically a question that is really hard to answer. So the the core idea is that if you have data, okay, if you have data, you will have to basically analyze it and figure out that is this data giving us good results? Okay, based on that, you will decide whether the volume of data is right. So of course, when we say volume of data, the record should be diverse, correct? If it's single record repeated again and again, it doesn't make sense. So and how diverse of the data, right? So if you think about the volume, you can never achieve the fully diverse volume. Okay, you can never achieve fully diverse volume. If you imagine that you have an Excel sheet in which you have three columns, right? Three columns, if you have three columns in an Excel sheet, an individual value could go from 0 to 100. What are the all possibilities? Okay, or think of it, if you have 100 columns, if you have 100 columns in your Excel sheet, an individual column can go from 0 to 100, right? Then what are the all possible values? It is 100 to the power 100. So you can never achieve the volume of data for 100% diversity. So it is based on what is available. It is not about choosing one over the another. Okay, it is not choosing one over the other. So it is up to what is available, and the importance is not. It's like saying that if you multiply A and B, which of the two, A and B, is important for the outcome. Okay, it's both. All right. So diversity multiplied by volume. Like if you have zero record and 100% diversity, the result is zero. If you have zero diversity and you have a lot of volume of data, then also the outcome is zero. So therefore, both the factors are important. All right. All right. So yes, thank you, Amandeep. That was good. Okay. So feature engineering, yes, you call it that part of data preparation, but that's basically a part of machine learning. Okay. Will knowledge of chatbot help in machine learning, deep learning? Yes, that would help. Okay, let's go ahead. Now, will we discuss when to use which activation function? Yes, we will do that. We will learn that part. All right. Okay, so this was a simple example. All right. So these are the various frameworks for deep learning: Theanos, TensorFlow, Keras, Caffe, and Torch. If needed, we'll give an overview of others as well, though our core agenda will be around TensorFlow. All right. A question, before I go ahead, I'd like to answer a question. And question is from Amandeep. I hope this course would be entirely online and that too on Sunday morning. So it'll be on Sunday and Saturday morning at the same time. Okay. And the course at the same time in the similar format, just that in remaining sessions, it is going to be very hands-on. Okay, because in this one, since it's a more generic session planned for a wider audience, that's why we have the more theory part, the introduction, overview, and so on. So, and the recorded sessions will be uploaded before Monday evening. Yes, that is done. By midday Monday, we upload it in case you miss. Also, the other option that we do is we allow the attendees to record the session so that they can have their copy instantaneously after the session is over. Okay. A question is also, I'm expecting some real life project case studies to be done in the course. So case studies would be there and the real life based projects are there. And some of the projects are real life, so real life that they'll be a little harder for the students. So, but we have started those projects now. Okay. And the good part about the deep learning is that any project that the project that we are doing as part of our machine learning one, the usual machine learning, the same projects, if they are not giving great performance, we will be doing the same thing in the deep learning. So that's one thing. So we are trying for a couple of projects recently, and so those things our students will be part of. Okay, and okay, all right. So yes, that we will do. Okay. Another follow-up question is also I'm able to install TensorFlow package easily, but it was said that it may be difficult. Did I miss anything? So yes. So if you are installing a local machine, though, so there is always this coordination issue. If you have larger set of audience, so always some people install it on home computer, and then when they are attending from the other computer, it's not available. Then the session performance, the overall effectiveness of session is generally not there. Second is when you are attending, say, a webinar or a session, running too many things on your desktop would not be too efficient. That's why we have set up the lab. Third is that Okay. Third is that if basically, if let's say we have to share data with you, you will have to you download the data and configure it locally, then it'll take some time. So using on CloudxLab makes life easier because I think some of the students who are already here in the session, they can testify that the experience they got with respect to using CloudxLab is actually good. Most of it's a good thing that I mean we built. I think that is now the example for all the industry or every industry that using a lab like CloudxLab solves a lot of problems of real learning as in the time was earlier, the time was in say 5 years ago, the time was that people would attend the class, then they will go to a computer lab to do the hands-on, while the model which we keep in general is we all do work, we all do things together. All right, as I am doing something on my desktop, you will also try to do a similar thing on your desktop and using in the lab, and that way the learning is very efficient. Okay, in case somebody is stuck, let's say you are stuck, I can just take a look at it and then help you out. So that way the overall learning is there. Okay. Last question is, I don't know programming, can we still learn ML? Yes, you can start learning Python. It would take like 3-4 hours and then start going ahead. All right, so that's one thing. If you know statistics, then also you can learn, but I would strongly recommend just go through Python. It will take like a couple of hours and learn. Okay, that will be most effective. Okay, and all right, great. Um, I know for many people, asking too many questions, answering too many questions could um, spoil the experience of the session, but as a matter of principles, as a matter of what we do, we ensure that we answer every question, because if you look around on the internet, if you search around, there are just too many videos, too many content already available. So the idea why people come to our classes, people attend or take our specialization is to get their questions answered. Okay, because that's one thing that is that's one thing that's very, very important. So we do not skip, we consider every question to be important. And what we believe is in the class that a question is not stopping the session. Instead, question is the purpose, question to be answered is the purpose of the class, because many other people would be having the same questions in mind, but those questions they are not asking the question. So the question could be quite helpful for rest of the class. Okay, so my always suggestion for our class is that always ask questions as much as possible, because those are the only things you walk out with after the class. So only the questions that you get answered are the main learnings that you will carry. And I have done the proper statistical analysis and found that only the people who are asking many questions, they actually walk out with a knowledge. Okay, so that's why we ensure that we answer everybody's question. We consider everybody's question as important. All right. So a question from Sergio is, what level of programming is necessary? I consider myself an intermediate Python programmer. That's very good. That will be good enough. The basic level of Python is good enough, and rest you will learn as part of the course. All right. Right. So yeah, so it's a good point from Ross that there is so much on internet for sure that I think I've seen a video of cats using machine learning to identify humans. Correct. All right. So yes, there is just too much of information around. Okay. Wonderful. Wonderful. So there are many deep learning frameworks. So this is what we were talking about. There are many deep learning frameworks, starting with TensorFlow, Theanos, Keras, Caffe, and Torch. We'll touch upon each of them, but we will focus mainly here. And we will also talk about Keras, because Keras is essentially a layer on top of TensorFlow. Okay, the Caffe, Torch, and Theanos will just give an overview at some point, but rest of it we can achieve everything with these two. All right. All right, so we are going to also, those who have not enrolled in the class, they may want to enroll the class. It is going to be it's going to be a course on deep learning. You will learn TensorFlow, the convolutional networks, the CNN, RNN, and autoencoder, and reinforcement learning from the industry experts. Okay, and and there'll be project and lab, there'll be certificate, there'll be best in class support. as well as there'll be option of one-on-one mentoring. Okay, so these are the topics that are covered as part of this course. We are starting today now after this on hands-on with TensorFlow. Then we will talk about we will learn how to create an artificial neural network and so on. So we will basically also learn the distributed TensorFlow, how to train a deep learning neural network, the convolutional neural networks, recurrent neural networks, and so on. Okay, we will also here at this point, the recurrent neural networks, we'll also cover something called LSTM, which was not planned as the time of making the course. And the course is little dynamic, so we keep on updating, adding things, even when we don't start plan. Even when we have not promised something, we will might add more things and the course might go beyond what has been promised duration. Okay, so we'll have autoencoders and reinforcement learning after that. All right. So be aware that this is the proposed curriculum, but there'll be additions. There'll be additions, and the time. So here we do have promised, say, some number of classes for these, but the time is a function of how well the class is going. Okay, so all right. So Brian, I'll answer regarding the TensorFlow as application as we go ahead. Okay, great, great. Those parts will be clear very soon. Okay, so that's the question that I would answer now. So let me just locate my slides. All right, so let me just locate my slide and okay. So all right, great, great, wonderful. So we are starting with, okay, so all right, so let's get started with TensorFlow. So far, what we have learned so far is what is machine learning. We learned about a couple of use cases, and we also learned what is deep learning, and we also understood that what does it mean by a simple neural network. Okay, so all right. Should we get started or yeah, there was one thing I wanted to give a demo of. Um, if you want, I can go over that. Okay, so here you see there was one thing I wanted to explain. Yes. Okay, so this is the playground of TensorFlow by Google. It's a visualization that how to classify the data, how to classify the data points, how to prepare a model for classifying a data points. Imagine that your data is like this and it needs to be clustered or classified. Okay, so how will it do? Had it been a linear data, it could have just drawn a single line using the standard programs. But since it's a very complex data form, then can the neural networks do that? Okay, so this is the example here. So we have three layers here, first layer, second layer, and third layer. This is the input one, and this is the hidden layer, and this is the output layer. Okay, so if we run it, uh,
See that? So it's basically trying to figure that out. See that? So it was able to locate this kind of, solve this kind of data. Now take a look at this kind of data, right? So generally, there are many techniques to classify the data. This is this one we are using is based on the deep learning, as in the multi-layer network. So we have, right? So okay. So now let me say that our data is like this. Okay. And we need to find classes in this data. So you can see that it's able to classify the data based on this. All right. All right. So we are able to, this was one demonstration. You could also give it a try at your own time. All right. So that was a simple one. So now let's try to get up and running with the TensorFlow. All right. So wonderful. Wonderful to have all of you in the session. Great. So first thing is, let's just take a look at how does the it look like. So we open the CloudxLab, and if you are already enrolled, you can just go to my lab and start. Otherwise, you can click on the start free lab, and that will take you there. So you just click on Jupyter here. Once you have gone to my lab, click on Jupyter. Okay, if you see this kind of screen, you click on Start My Server. If you see the login password, then copy paste this login and password there, your own, and then you click on Start My Server. Okay, so what is Jupyter? Jupyter is a web-based interface with which you can interact with a file system of the server. You can interact with the Python program all through the browser. Okay, all through the browser. Okay, yes, Guru, you have raised a hand. Okay, so you can see that this is the folder structure where these are my files. This will be empty for you. Okay, maybe this is a folder you already have in your home drive. Other than that, for you it will be empty. Okay. All right. Next is we could just open the here. Either you could work in Scala, you could run in Python, you can work with R, and you can also open a terminal to get started. Okay, so we'll just keep the terminal open. All right. You could create a folder and other things. These are the files at the server. Okay, please note that this is not in the Hadoop. If you want to interact with Hadoop, you can go into Hue and you can interact with Hadoop. All right. So, well, this is mainly the this is mainly the this is mainly the what do you say, the file system in your home drive. So this terminal that you see is a place where you can type any command. You can type any command here. Okay, and also you can see this. All right, so here if I say ls, pwd means present working directory. It shows my current directory. Ls means this is my home, this is a list of my file. This is the list of my files and so on. If you prefer the command this kind of way, you could say R here. Okay, let's say you want to run R, you can just start with R. Okay, the other thing, let's say you want to work in Python. So if you want to just work on Python too, okay, question is, how did I enter the shell? Click on new and click on terminal. When you are in the Jupyter, you can click on new or terminal. Then you will see this Jupyter terminal. I prefer Jupyter terminal because that one basically keeps the session open. and I don't have to log in again. The other thing you could do is you could just click on Web Console. That will also give you a similar environment. Okay. All right, that answered the question. Question from Pratik is any reviews on Jupyter Lab? I've not experimented with Jupyter Lab, so maybe once I experiment, I can answer. All right, so okay, so this is all right. So this is a holistic environment where you can interact with Hadoop, Scala, Spark, and R and Yarn and everything in a single environment. Your data will be here, and you can interact with the entire ecosystem, or you can build the softwares where you can utilize all Hadoop and multiple of these components. Okay, so 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 since our users have been from varied background, they needed all kinds of interactions between different components. So it made a lot of sense to have all the components together in the same lab instead of different lab for different people. Okay, so that's one of the reasons we do not restrict people from using a particular lab. Okay, let's start. So this is, if you want to work in Python, you can use Python here. So you can see that Python 3 is here. Okay, for me. And here, I think the TensorFlow will be there. I think so. Yeah, it is there. You can press Control D for coming out. So that was a quick overview of the console. This is where the one is. So traditionally, we used to interact with Python console here like this. So we'll type the program, press Enter, it'll give the output, and this is what we were doing. Now, in the Jupyter Notebook, there is something called a notebook that when you click on New Python 3, the same thing happens as a nice user interface here. Okay, this is a nice user interface where you can type your code and get the answers. Let me write like most complicated code. Is to press 3. All right. So again, for most of the learning purposes, you don't really require GPU right now. Okay, so you can go ahead with the normal computer. So do not worry about the processor. Okay, all right. So most of the TensorFlow and all these things can run very well without the GPU. Okay, a question from Anonymous is, what is Anaconda? Okay, what is Anaconda? The Anaconda is basically the package which has the Jupyter and everything in it. So in order to install most of the machine learning or data science tool, you generally install Anaconda, and it brings, or it is basically kind of a suite of components which is open source. So we also have installed Anaconda in order to install Jupyter Server and things like that. Okay. Good question. So, question from Pratik is training CIFAR 10 took more than a day for me. Okay. Okay. So basically, when you are working on a larger data set or you're working on a complex neural network, you might require a bigger GPU. But for the learning purposes, the way we have tuned it is that we should be able to get it done using a normal computer. All right. So that way. So, all right. So I think, yeah, good. Now, next point is that let's just get started here. So is everybody able to open their Jupyter notebook and is able to write this complex program 2 plus 3? Okay, all right. So only 3 people? All right. Good, good. Okay. So is everybody able to do this? Like the basic one? That would ensure that you are all up and running with the Jupyter. Great. All right. So the main idea is that once you get started with the tools, you can do a lot of things easily. You could just click on new and click on say Python 3. Okay. So you could open Jupyter, you go to my lab, click on Jupyter, and then click on new, and then click on Python 3. All right, Shiva? Great, great. So, all right, so that means your notebook is ready. Okay, okay. A question is regarding the versions. Sorry to mark it this. Um, okay, let me answer Madhav's question. Question is, if we are doing ML, which version of Python to use better and why? So we use Python 3 because there's not much of a difference, and most of the components now support Python 3. So it's better to use Python 3 instead of Python 2. Now I think everybody is started to move to Python 3. Okay, great, great. Everybody is able to access the notebook. Wonderful. So that means my first, the first part is done. Good. Now, once we are there, right? Now let's go to once you have, okay. So once you have logged in into the um, Jupyter, open the Jupyter console. Okay. How do you open the Jupyter console? Click on New and click on Terminal. Then you will get the console. Okay. And in the console, you have to um, get a copy of the repository that we have already done. So this is our repository here. Okay. This repository basically hosts most of our code related to machine learning. Okay. So you could give it a shot. All right. Now we are just going to clone this repository. Okay. We're going to clone this repository and I'm going to give you this command. Okay. So go to the terminal and clone this repository. Okay. Press enter after typing this command. For me, since I have already ML in my home drive, it has not created it. For you, it will create. Question from N is that network file descriptor not connected. Okay, try again. All right, please try again, N. All right. If you've already checked out those who are already part of the course, they don't need to do this. They can just You can just go to ML folder and then do git pull. Okay, so what we are trying to do is we are trying to bring the code from our repository to our home drive. Okay, so these steps are something that actually kill your inertia or hesitation to start with new thing. And once you are up and running with this, rest of the things will be far more easier. All right, should we go ahead with the next step? Okay, so here since for me the project is already there, I'll just change the directory to ML. Those who already had checked out before in the previous session, they could just go to cd ML, meaning go to the ML folder and say git pull. Git pull brings fresh code from the server. Okay, if you have made any changes to the local drive, then it'll give an error. Those changes you will have to either commit or will have to resolve that. Okay, so basically I'm able to update my code. It was already updated. Now if you go back to your home drive in this here in the first window, then you will notice a new folder there. You'll notice a folder. Let me just, since I have too many folders, I'll sort this data, sort the folders by last modified. Then you will see this ML. Okay, this ML folder contains deep learning directory. Click on that. Okay, it has this notebook called tensorflow.ipnb. If you click on that, it will open the notebook with some of our code. All right, are you able to open this? So all we did is we did the git clone, we took the code here, then we went back to the folder structure, clicked on ML, and then clicked on deep learning and opened this notebook. All right, this notebook is what we are going to follow. All right, I would suggest all of us, if you have not taken the access, you can take the lab access and you can try these steps. The idea is that these are the only hurdles to get started. Once you are up and running with this, then you will not have this hesitation to try out things. You see a piece of code, you want to try something, just come here, open a notebook and start working. Okay, a question from Rajesh is having trouble accessing terminal. What error are you facing, Rajesh? So you are able to see my lab, then are you able to open Jupyter? In the Jupyter, you have to copy paste this password for the first time. And then once Jupyter starts, you have to click on Start Jupyter. And then in here, you can click on New Terminal. Then terminal will open. Okay, terminal will open. And inside the terminal, and you can do git clone. Okay, okay, so all right. So a question from Minta is, can we run PySpark with Jupyter Notebook? Okay, good question. Good question. I'll actually suggest this one for you. I have written this the one with the one that comes with Jupyter Notebook, usual one, the Jupyter server that doesn't have PySpark. So we had to do the running PySpark in Jupyter IPython. This is what we have written earlier. Okay. Just a second, not this one. Not this one. Just give me. Yeah, this should be good enough. Yeah, this part you can use. Okay. So if you are planning to run PySpark with Jupyter Notebook, you will have to launch your own Jupyter server. That is also allowed in CloudxLab. So you could launch your own Jupyter server, and there you will have separate folder structure similar to this one. And okay, a question from Brian is, I could not copy paste, or maybe this Windows is not allowing the copy paste system. So you can just type, you can click on that I here and see the login password, and then you can type. Okay, thank you, James. So you could also use Control Shift V. That should also work. Yes, Parag, you have raised hand. You can ask a question using Q&A. All right. All right, Rajesh, are you able to resolve? Guru, you have raised your hand. Okay, you have a question. All right, great, great, wonderful. And all right, so this way we are able to open our notebook. This is the notebook that we are going to follow in today's session. All right. So again, I would request everyone to not just be the audience, be part of it. Please participate and please. Okay. So please, um, I would say do the hands-on. That's the only way to learn anything. Okay. You can never learn anything without doing hands-on. All right. So whatever we talked in the first half, you may not retain that part, but what we are doing now, you will retain that. Okay. A question is, after git pull, how to access notebook? So we went to this git clone, right? And in case for me, it was already existing. So I went into the folder, the one that was created earlier, and did git pull. That means it is saying for me that it is up to date. Then you can go to this folder here, and in the Jupyter, then you can go to this folder, click on a folder called ML, click on a folder called ML, okay, and then and then click on deep learning. A question from Bharat is, uh, okay, so you have to exit that Python shell. You are inside the Python shell, you say Control D, and then you, from the console where you see the dollar here, the first line, let me just, it's also a common mistake that would help you. So here what you have done is you have started Python and then did this, right? So yeah, you could just quit, or you could just quit Python here and come out of it. At here, when you see this prompt, there you do the git clone. Okay, there you do the git clone on this here where you typed Python. All right, that's the only mistake. Good, good going. So it's okay to make mistakes, and uh, I think that's the only way to learn. Okay, do the hands-on, you'll make mistakes and you will learn. Okay, so all right, so we are all up. So in the folder, are you able to access Rajesh now after git pull in the ML deep learning and the notebook? All right, I made by mistake somebody. Okay, good. Good. So wonderful. So here we are. We are up and running with our notebook. That means we can get started. So for me, it is showing 1.4.0. We'll have to take a look at this one because different people have different servers. Okay. For me, it is 1.4. Okay. For me, it's E, and some people would be having F, some people would be having G. Since we have done the load balancing between the users, therefore, some people could be having different set of packages. Okay. So we will have to take a look at this one. Okay, this is the older version, so we'll update this. I'll make a note of this to update this to newer version of TensorFlow on E. Wonderful. So great. For now, it'll be okay. In the next, by next session, we'll be updating this version. Okay, we'll be reviewing it. Okay, looks like G also has 1.4. Okay, great, great. I think, yeah, I think the current version is 1.6. I think so. Let me just check if it is stable and then we can go ahead. Okay, so the next thing is we are going to do is we are going to check if TensorFlow is available and the version is available. So here we are. So we just check this part. So import TensorFlow basically imports the TensorFlow library. And then you can say print TensorFlow dot version. You could do the same thing. You could do the same thing from the console as well. Okay, you could do the same thing from console as well, and it should be good enough. Great. Now moving ahead. So what is TensorFlow? TensorFlow is a powerful open source library for numerical computation. It is fine-tuned for large-scale machine learning. It was developed by Google Brain team. It powers many of the Google's large-scale services, such as Google Cloud Speech and Google Photos and Google Search. Okay, so now the basic principle behind TensorFlow, the one that made it, the one reason why there was a new library created, even though there are many libraries around doing the same thing of machine learning, why was TensorFlow created? The basic principle is that we first define the graph of computation. Instead of doing the computation instantaneously, we do the computation as a graph. For example, imagine that we would like to evaluate this expression. This expression is x squared into y plus 2. Okay, imagine that we have some values for x and y, and we would like to compute this expression, right? So to compute this expression, we could do two things. One is we could instantaneously do evaluation, or we could do it when required. So in case of TensorFlow, what it does is it creates this graph of expression. Every node represents a expression in itself. Say, for example, here this x is one value, here y is one value. So when you multiply here, you are multiplying x with x, here you are multiplying x with y, here plus is basically adding up y and 2 and so on. So you see that the graph, if you let's take a look in classic Python. If you have to do same thing, like we have x equals to 2, y equals to 1, and the moment we say f equals this, suddenly the value of f is instantaneously computed. The value of f is instantaneously computed. So you can see that here it's an instantaneous evaluation, while in case of TensorFlow, we have lazy evaluation. We define x and y, we define f in terms of x and y, and when we need, we call evaluate function on f to get the value. Okay, so that's what is the core idea behind the TensorFlow. So every computation that you have seen, that all is expressed in terms of a graph of operations, and that's how we do the computation in case of TensorFlow. Okay, so TensorFlow runs this graph very efficiently using optimized C++ code. So TensorFlow is written in C++ and it's very optimized to do mathematical computation. And question is why to do this? Why? What is the point? What is the point of having a graph carried around instead of just a value? Instead of just computing the value, we do the we do the lazy computation, right? So the idea is that this graph can be further broken down into subgraphs, and these subgraphs could be given to different GPUs or different CPUs. So say, for example, this part of the computation could be given to somebody, and this part of the computation could be given to another another processor. And once both the parts are done, then we can do the addition. So this essentially ensures that distribution of the computation is possible at a very granular level. Okay, instead of at a very high level, it is making it possible to do the computation at a very lower level. Now, the downside of this approach is, what are the downside of this approach? Most of the algorithms, most of the programs will have to be rewritten for TensorFlow in terms of graphs. Okay, that's the one downside. So TensorFlow also supports distributed computing. We'll cover distributed TensorFlow later in the course. We can train a network composed of billions of instances with millions of features in each. Okay. Um, Basically, if the data is, if data has lot of complexity or a lot of information, then we can train the network which has many instances and which has millions of features. So we'll show you what it means by training a network. Okay, so it can run on a desktop, it can run on all kinds of devices, including now, probably in recent versions, it is able to run on Android. That means that once the training is done, or once you have trained the model, you can actually run it anywhere, as well as you can train it on the Android. Okay. Okay. A question from Bintao is that could you share the slides of TensorFlow? Sure, sure. We'll share the slides of the TensorFlow. Maybe okay. Somebody from my team can help out with. Can you share the PDF? I'll just ask somebody. Okay, so yeah, I will soon be sharing. All right, great. A question from Brian is, I could not copy and paste on Windows. Is it normal? So yes, sometimes on some browsers, the copy paste isn't allowed. Specifically, I think IE it doesn't work. Okay, all right. Wonderful, wonderful. So now, coming back to it, so you might be thinking that for everything, do we need to create graphs? No. There is a high-level library available called TF-learn. TF-learn is compatible or designed in the same line as scikit-learn, and you can train machine learning models with just few lines of code. So just like scikit-learn, scikit-learn is a very, very simple library for machine learning, and the TF-learn is designed in the same way because the the because having this kind of a graph brings complexity in the computation, and therefore it it would basically take a lot of time to write even the simple code. So what they have done is they've created something called TF-learn, which is designed on the same level as scikit-learn. Okay, it's designed in the same way. Okay, there are many high-level APIs which are built on top of TensorFlow, which is one is called Keras, other is Pretty Tensor. Keras is quite popular and is used. Okay, so Python API offers flexibility to create all sorts of computations, including any neural network architecture. Okay, so the highlights of there is a C++ API as well for TensorFlow. It includes highly efficient C++ implementation of many ML operations. Also, it has C++ API to define our own high performance operation. So we can also use the C++ for interacting with TensorFlow, and we can, for both using existing algorithms or creating our own algorithms, we could use either of the APIs. Okay, so TensorFlow gives you a great visualization tool called TensorBoard. It allows to browse through the computation graph. So as you launch something, so let's say you're doing some work and you would like to see the visualization, you could use TensorBoard in order to view the learning curves and more details. All right, so those are, and it is basically, it's open source and it has dedicated team of passionate and helpful developers. It has probably one of the most popular communities on GitHub, and therefore TensorFlow is the one that is actually winning the entire machine learning game. Okay, specifically the deep learning one. Okay. All right. So these are the various available deep learning libraries that you must have seen in past. One is Caffe, Deep Learning for J, H2O, MXNet, Theano, and Torch. The principles that we're learning in this course will be applicable to all. These principles will be applicable to all, and the TensorFlow is this TensorFlow is the one which we are going to go ahead with. Okay, so all right, now let's try to create our first graph and running it in a session. Okay, so first of all, we are going to do this. All right, we are going to do this. Then I'll again give you an overview of what's going on. Okay, so PyTorch is becoming popular. It's actually good. PyTorch is good. So we'll see if we can include PyTorch in this course. Okay, and see how we can use it. All right. So even though we had planned for some topics, but we will keep on including if needed. All right. Good. So we are going to create our first program, and the program is very simple. The program is going to do the same thing. This program, what it did was it computed x squared into y plus 2. Now the same thing we are going to do here. Okay, here this is just common import, so you can just import this part. How do you run some command? Here in case of Jupyter, just click on the box and say shift enter. Okay, shift enter. Okay, so, and this is where we go. Now, so you can see that in the beginning, this is the first command that we are trying to execute. So we are saying import TensorFlow. we are calling the reset graph. Okay, we'll talk about why reset graph. Okay, then we are saying tf x equals tf dot variable. Okay, now we are defining a variable called x whose value is 3. Then we're defining a variable called y whose value is 4. And then we are saying f equals this. Now what is the difference between the above code and this? When we say f and press shift enter, it doesn't give the value. Instead, it says that it's a tensor. It says that it's a tensor and it's an object. It's not, it doesn't have the value. How do you get the value? So to get the value, you need to start a session. Then we run the session initializer, the value initializer for X, value initializer for Y, and then we run session.run. Now the results will be evaluated and will be assigned to the returning value. So you can see that the answer is 42. Okay, while the answer, because the earlier the answer was 3, if you put 3 and 4 here, you should get 42. Okay, so you can see that it has basically done the evaluation exactly the way we have done earlier. Yes. Now, this is the code that looks a little bit bigger, so we're going to make it little smaller and simple as we go ahead. So what we did here is a very important thing that we did. What we did was we created X, we created Y, and then we created F. Okay, and this is F is nothing but a graph of operations. F is nothing but a graph of operations, and how to evaluate F is by the way of this. Okay, so you can see that. All right. Now so there is something called a session. The value of the graph is always inside the session. So we are initializing a session. We are initializing the session, and then we are running it here, and then we are printing the results. Okay. All right. So this, and then once we are done with the work, we are closing the session. The session object is part of the TensorFlow. Okay. Session object is part of the TensorFlow. We are calling a method called session that is creating the session out of the TensorFlow label. So we can have multiple sessions at the same time. Okay, so here we are not hardwiring, we are just saying that we are defining the variable X and Y with their initial values as 4, and later on while evaluation we can actually specify different values for X and Y. Okay, so that's why we are putting it as variable. We could actually, well, at the time of evaluation of a session, we could specify different values for X. All right. So there are a few questions, let me answer. Priyanka's question is, any reason why only C++ was used to develop TensorFlow? Mainly for performance reasons. Okay. A question from George is the distributed computation. Thank you, George, for that answer. Now going ahead with next question. Question from Brian is, I could not copy paste in Windows. Okay, is it normal? So sometimes, yes, the copy pasting is little buggy. So sometimes you might have to just type or just log in like that. Okay, and that could, yeah, that could also just have to take a look at other shortcuts. And I would say that just message me with at reaches at CloudxLab. Let's take a look at what could be done. Try Chrome or something, and that might work. Okay. Uh, all right. So a question from Pratik: can we make use of TF in ML2? Yes, of course. We will learn that part. Okay, we'll learn that part. A question from Raghu, can TF take care of order precedence? Of course, of course. So order precedence, basically let's say the order precedence is basically first driven by the directed graph based on what comes before and so on, right? A question from Noor is everything which is possible in scikit-learn can be done in TensorFlow? If yes, is it a replacement for scikit-learn? So most of it could be done in TensorFlow, but I'm not sure if TensorFlow could be a replacement for scikit-learn, okay? Because scikit-learn is a comprehensive suite of components. The thing is, scikit-learn is a layer. Scikit-learn is a layer under the hood. Each algorithm was implemented in C, C++. Okay, that way, scikit-learn will not be replaced with TensorFlow. Maybe the scikit-learn's implementation might switch to TensorFlow. Okay, because TensorFlow does not give a very friendly UI API. It basically gives you this way to design the algorithms, while scikit-learns give you the very neat API. So I think scikit-learn will remain there, just that just that it will start using TensorFlow for most of its work. Okay, a question from Chandrasekhar is that hardwiring x and y to a constant value, is there a generalized way? Okay, so all right, good. So is there a way to generalize? Okay, good question. So yeah, that's what I was explaining. So here, this value, even we are giving them a name. At that later time, when we do the evaluation here, we can actually pass the values for x and y, and then different values than the one that we have defined earlier, because we have defined them as variables. A question from Pratik: can we make a tensor? Yes, we have. Yeah, answered the question. All the variables can be initialized with one command. Yes. All the variables can't be initialized with one command. Okay, so actually you won't need to. You just can have different commands. Okay. Can we run these commands in terminal as well? Yes. Will you go ahead, please? They will work fine. Okay. So reset graph is the one that we have defined above here. Okay. So actually you can just run these three commands happily. I'll just show you Python and say import. Okay. And then I say this. All right. So it seems to work. Let me just try these things also. So you can see that it has given the 42 as the answer. So that was our hello world in TensorFlow. Okay. Now we're going to talk about a little bit more. Okay. Good. A question from Malik Ram is, can TensorFlow demo session have some credentials for practice purpose for one today rather than subscribing? So actually, though, that's really hard to have the same credentials for everyone, because everyone needs to have their own environment. That's why I wanted to this subscribing. Subscribing is free, by the way. Subscribing is absolutely free. Just the credit card needs to be entered for KYC purposes. We don't retain any of your information, so don't worry about don't worry about the security, because that is taken care by Stripe. So the we don't have any of your data, so you can be rest assured that your credit card will be safe, and you don't need to save that at all. Okay, just so we need a KYC to be done. The KYC as in know your customer or know your consumer, and that needs to be done because we are providing a full environment. If in the environment there could be a denial of service attack, there could be multiple other things that could be done, and because of which we are being forced to give the KYC. Otherwise, we would be more than happy to provide it for free entirely. It is for free. Question is Stripe available for India? So the company is a US company. Our CloudxLab.com is registered in the US in Delaware. So okay, so it's that's why. Okay. Question is, okay. Thanks, great going. I'm able to execute things smoothly. Really happy to know that. Okay, next question is from Noor. So here is the following question. So don't have implementation of ML algos in TensorFlow. So how regression classification is done via TensorFlow? Okay, good question. Question is that in TensorFlow, we don't have implementation from algos in TensorFlow. There is, that's what TF-Learn and other libraries are doing. They are implementing the algorithms in TensorFlow. Okay, so that work is already started and people are working on that, implementing those algorithms. Okay, a question from Pratik. Sir, will Keras give compatible results of TF? Yes, Keras is basically one layer on the top of TensorFlow and gives you almost all the algorithms as well. Okay, so is there a way to see an image of TensorFlow graphs? Yes. Is there a way to see the TensorFlow? We'll cover this very soon. Okay. And so TensorFlow, I doubt if it provides you the graphical representation. You might have to use the other tools. We will learn that part as we go ahead. Okay. And a question from Siva, I get this error. Named reset graph is not found. Okay, correct. In the console, that's why I did not type this particular code because the reset graph we have defined here. We have defined a method called reset graph, our own, and that's what it's doing. All right. I'm coming to that, Binta. Good question. All right. So good. Great. So far, yes. The next point that I would like to discuss is this is the part which we use to create the graph, right? We created a variable, we created another variable, and then we created an operation with these variables. So here, this part is a constant, and these x and y are the variables, and these f and plus and all the multiplications are the operations. Okay, so this code does not perform any computation. It just creates a computation graph. Even the variables are not initialized at this point. Even this assignment did not happen. The x3 was not assigned to x. It was just x is just an object of this particular class. Okay, now how do we start the computation? To evaluate the graph, we need to open our TensorFlow session and use it to initialize the variables and evaluate f. Okay, so that's what we did. TensorFlow session, what is TensorFlow session? TensorFlow session takes care of placing the operations onto the devices and running them. It also holds all the variables required. So here we are saying that tf.session is creating the session. Here this one is initializing the variables, and this one is evaluating the operation, evaluating the graph. Okay, so session.run F evaluates it, and then we are printing the results. Okay, and then we finally close the session. All right, now there is a better way. There is a better way. Better way is using with syntax. In Python, there is something called with. What with does is generally, let's say you have to open a file and close a file. So what you do is you always use with. With automatically closes it and after opening it. Okay, so everything as soon as this block of code in Python, the way the block is detected is based on the tab spacing. So all of the lines that are at the same indentation level, they are part of the same block. Okay, so basically when we are saying with tf.session as ses, okay, we are saying x.initializer.run, y.initializer.run, and result equals f.eval. So same code, what it was here is made far more simple as this. Okay, far more simple as this. So you can see this is here. So we are saying, okay, here with tf.session as session and this. All right, we'll continue from here. We will learn more parts about understanding this graph. We will also go into more details why exactly we need this graph kind of computation. Okay, all right. So yes, a question from Neha Jain is it possible to do session.run? It should be possible. We'll learn it as we continue from here. All right, in the next session. All right, great to have all of you in the session. I look forward to see you in the course. You can enroll for rest of the classes. The next classes are going to be on the next weekend, and we will continue from managing the graphs. The course is going to be very hands-on. We are going to learn basics, and then we are going to implement the projects and see how we can optimize our programs better as we go ahead. So we will learn all part of the machine learning as we go. So you can go to home page, okay, and there if you come down a bit here you can view the details, and here you can enroll for the course. Okay, you can go ahead and enroll for the course. All right, so these are the various parts that are covered as part of this course. We'll be including more parts like LSTM, and there was one more part that was talked about. Those parts we'll be including, and I look forward to see you in the next session. Thank you, everyone. Have a great day. Thank you, Prateek. I'm really happy that you found the session to be informative. Thank you, Parag. Uh, I'm happy that you liked it. All right. Thank you, Rajesh. I'm happy that you find it super useful. Okay. I look forward to see you next week. All right. Thank you, everyone. Thank you, Noor. I'm happy that you found it excellent. All right. Thank you, Anil. All right. Okay. All right. Wonderful. Wonderful. I'm very happy that you really liked the session. And a question from Sergio is that can we use the paid course for bragging points? Okay. So actually in the resume, yes, I think, yeah, you can actually, what we are going to do is we're going to start with a couple of projects and we're going to include the students. We already have started two projects with the students. And lucky for us that most of the students that we have are really doing good and so on. And all right. Thank you, Brian. I would like to make a correction that I'm not a doctor. So, and if that is not your expectation. So thank you, Brian, again for the great questions and great answers. And all right, we'll be sharing the PPT and the recordings with all of you. All right, I'm really happy that you got the idea about what machine learning is about. That was basically the objective of the session. Thank you, Siva. I'm really humbled by the response of all of you. Uh, uh, okay, so I look forward to. All right. So great, great. So come over, inform your friends. If they are students, they can take up the lab for a month or so. And if they are just want to learn and get started, a lot of content is free on CloudxLab. So come over, use the lab, practice things, and that's the way to go ahead. All right. So yeah. All right, so stay connected. Be on our discussion forum. The discussion forum is quite popular, so come over to the discussion forum. There are lots of students and the learners who are participating there. Ask questions, answer somebody's questions, and that's how we all are going to learn better, and we are all going to help each other. All right, great to have all of you in the session. Thank you, everyone. Great to have the session. All right. Thank you, Ross, for a great sense of humor. And That's the one thing that's machine learning can't teach. All right. Great. Great. Bye bye. Have a good day.